This is Lecture 8, Designing and Implementing Classes, a Fraction Class. This covers section 6.4 from our textbook. Now, before going directly to the material of the lecture, I will ask you to look at a few things here. I have my textbook here, oopp.pdf, which I have shared with you if you remember. This is chapter 6. 6.4 is here, okay? We will be seeing television class soon enough, but for some reason our syllabus overlooks 6.1 and 6.2. In my opinion, these two sections are very nice, very well written and quite useful, okay? So take some time to read section 6.1 and 6.2 closely. So I will myself go over the point classes mentioned here, but it will help you if you read these independently yourselves, okay? Now the files, there are 4 files I would like you to have access to: fraction, GCD, intro classes, and point classes. I have shared those with you on Dropbox, in lecture files, lecture 8 files, right? Also in Blackboard, okay, in lecture 8 files, okay? So you will have to download these and then you'll be able to play with them yourselves, okay? Download, these are .py files, .py files. You won't be able to open them, you have to download them. Okay, so let's continue with the lecture. So as I said, it's best to first let's design classes by example. So before going to somewhat a detailed class here, let's start with the simple classes, okay? So I want you to have a look at the first file here, intro class, okay? So I have created an examples.py file to play with this, okay? How does one define a class? Well, very simple. There you go. I want to class, name of your class. Name of my class is animal, colon, and nothing, pass, okay? Past is a syntactic way of completing the definition without adding anything to the definition, okay? So let's run this, save and run. It ran without any problem, okay? So this is our very first class. We have defined our class animal, colon, pass. So can we construct any objects here? Let's see. LE equals animal, okay? So this is what it means to be constructing. So I'm using the class as a constructor. I'm using a constructor, the constructor of the animal class, invoking it, and that constructs an object. That object, so LE has been assigned the object constructed over here by animal class. All right, let's look at a tortoise. Let's construct a tortoise. So again, I'm constructing a class, an animal object by invoking animal. There you go. What is animal? Okay, it tells me it's a class. What is LE? It tells me it is an animal object. This is the location where LE is stored. What is tor? It is also an animal object. Note, tor is different from LE because the locations are different. So that tells me they are different objects. Okay. If I want any more information about any of the objects I create, this is a nice way. Print LE dot underscore underscore DICT underscore underscore. What that means is dictionary. Okay. So DICT stands for dictionary, double underscore there. So right now LE has no more information. Well, of course, our class was the simplest of all. No information was spaced, no attributes, no methods, nothing. So it is empty. Likewise, print tor dot underscore underscore dict. Okay, nothing there. All right. So let's improve this a little bit. Bring in a function. Yeah, make it more interesting. All right. So what does this say? In my class, I have defined a function print info self. What does self stand for? Self stands for the particular object you have created. Okay, you have constructed. In this definition, print info function, what is the body? It's the body just asks the function, the you to print, hello, I'm an animal. That's all. Okay, save, run. Notice the computer has restarted, the compiler has restarted. So I have to build LE all over again. I have to build Tor all over again. Okay, now let me see what is in my elephant dictionary. Still nothing, because there are no instance variables. So what is this print info good for? Well, it lives in animal class. Print info is the function in the animal class. So that dot tells me this lives here, and I'm going to invoke it on Ellie. Aha, so it worked. It did exactly what I asked it to do. Print, hello, I'm an animal. So let me play the same game. Invoke the print info function which lives inside animal class. So animal dot print info on Tor. Okay, it worked on Tor as well. So this is quite clear. Here is another way of getting the same output. le.printinfo. There you go. Tor.printinfo. Okay, so printinfo is not just a function in the animal class. It is quite attached to the objects we have created. All right. So a function which is uh, related or quite attached by qualified by the self, these are called methods. Okay, so this is a method. All right, now now I would like to give my elephant and my tortoise some names. So let's see. Ellie first name, Ellie dot F name is gentle. Ellie dot last name, L name is giant. Okay, so I did this. Recall here print le dot double underscore dict double underscore was empty. It was an empty dictionary. So now let's look at the dictionary for elephant. Aha, so now the dictionary has been populated. So these are called instance variables. Variables for the instance elephant. So dictionary gives me the instance variables for my object, for the objects constructed. So suppose I want to see the dictionary for my tortoise. It's still empty because I did not create these. All right, I have not yet defined any instance variable for tortoise. So what if I wish to define automatically for every object I create? I don't want to have to write instance variables one object at a time. Let me work with the class definition itself. And that's where you have the other option. Instead of definition, let me use a place within my definition of the class, a place where first name, last name, age for every object can be defined. Okay, so define, there is a special method called init double underscore init double underscore. This is called instantiator or constructor. All right, instantiator. So this is where this is what helps you to create instances. Not instances are objects. Okay, this is what helps you to construct objects and assign values to your variables. For each object you will have these variables. So unlike the previous case where we had to specifically define these variables for elephant, here they automatically will be created for every object you construct. Okay, save, run. All right, so I have again restarted my compiler here. So I need to restart my I have to redefine LE. So I tried the same definition, same constructor, LE equals animal, no parameters, and it's giving me it's complaining. It's saying it's missing 3 required positional arguments: first name, last name, and age. Okay, so there are 3 arguments it's looking for. LE equals animal, first name gentle, second last name giant, say age is 20. Now got constructed. What is LE? It's an animal object saved at this place. So what is Tor? Animal, sage, thinker, 80. Okay, tortoises are known to live long. What is Tor? That's an animal. So let me see whether both LE and Tor have dictionaries. No. So let's see what is the dictionary for my elephant. Look at that. It's populated the dictionary. What is the dictionary for Tor? Very good. So, but now if I say le.printinfo, looks like I have lost it. Printinfo, the definition of the function is gone. So let me get the function back. Remember, a function, okay, qualified for every object, that is called a method. Okay, so the very first most important method here is, because of double underscores, these are called special methods. This one is the instantiator. It's one of them. It's the most important method you need. So now let's unindented. Okay, I'm sorry. So this is not indented properly. There you go. Dangers of cut and paste. Okay, so let's see. Okay, so okay, so good. My suggestion, I'm running out of time here. Try and implement this. Okay, construct objects and play with this. I'll continue in my next video.